Hello everyone, we are group 2 and we'll be presenting a topic keylogging attack using binary evasion technique and detection using Wazuh SIEM tool. So these are my group members. This is SAQUIB, MANDEEP and CHIRAG. So MANDEEP will begin with the introduction.
Hi there, my name is Mandeep and I will be starting with the project. So first is our introduction. In this project we are building a keylogging attack using Python that can bypass the Windows security of Windows 10 and 11 using a technique which is known as binary obfuscation. Basically it means that the keylogger can hide its true purpose from the antivirus and can insert into Windows 10 and 11 without the antivirus detecting it. So in this slide we will be talking about the keylogging attack and evasion technique. So basically we are focusing on developing a keylogging using Python, as I said before. The keylogger will be designed to run quietly in the background, capturing everything that's been typed on the keyboard. To make it harder for the program to detect it, it will be using a tool called as NMPT, which converts the Python script into an executable file. This process is known as binary obfuscation, which basically changes the key signature of the keylogger, and so that it doesn't look like a malware to the defender. By doing this, we can understand how the attackers can evade detection, and it's a crucial step in learning how to defend against such threats. Moving on, the next slide will be explained by my friend CHIRAG.
Hi everyone, my name is CHIRAG. So I will be explaining about network setup and diagram. So in this setup, the keylogger is installed on a test machine, silently capturing every keystroke and securely sending the data to a remote attack server. To counter this, we have implementing the Wazuh SIEM tool, which monitors the network from any unusual activities. If Wazuh detects anything suspicious like unauthorized data transmission, it immediately raises an alert, enabling us to respond quickly to potential threats. This diagram shows how the keylogger operates within the network. The keylogger on the victim's PC sends captured keystrokes to a remote server controlled by the attacker. Meanwhile, the Wazuh SIEM tool hosted on another server monitors for suspicious activities. If Wazuh detects the keylogger activity, it triggers alert, allowing us to quickly address the threat. This highlights how the network steps flows from infection to detection, emphasizing the importance of active monitoring. So moving on another slide, that is methodology. In this project, we followed a structured approach to achieve our goals. First, we set up the environment by installing Python and its necessary libraries and the NMPT compiler. We also configured the Wazuh SIEM tool within our test environment. Next, we developed the keylogger using Python, ensuring it runs steadily in the background. Once the keylogger script was ready, we compiled it into a standalone executable using NMPT, which helps in hiding the script from antivirus programs. After compiling, we tested the keylogger to ensure it bypassed Windows Defender on both Windows 10 and 11. Finally, we have integrated the Wazuh SIEM tool to detect the keylogger's activity, sending up rules that triggers alert whenever suspicious behavior is observed. So for the next slide, I will invite Saqib. Thank you.
So hello everyone. Now I will be discussing about the detection and the mitigation. So like to effectively detect a keylogger activity, the Wazuh SIEM tool should be implemented with the custom rules and real-time monitoring setup. So what this setup does is it ensures that when the suspicious activities are like identified and the alerts are triggered, it like for allowing for the timely mitigation of the threats. So like additionally, to enhance the overall security, it is important to deploy the IDS and the IPS system. So like enforcing strict firewall rules and regularly auditing the system logs. And coming to the access control, following the best practices such as like enforcing the principles of least privilege, implementing multi-factor authentication, and keeping the software updated and patched. Those are like the crucial stuff. So these combined measures are essential for building a strong defense against potential security breaches. So coming to the second slide, it is a conclusion one. So developing and deploying a keylogger, like it can greatly enhance understanding of how malware operates and how the challenges in creating it. And like at the same time, using these tools like Wazuh to detect and respond to to threats in real time provides essential hands-on experiences. So by combining offensive techniques like crafting malware with defensive strategies such as let's say monitoring and alerting, uh, like a well-rounded understanding of cybersecurity is achieved here. So this balanced approach is crucial because it like mirrors the real world, which needs to be both understand and how attack happens and how effectively to prevent them. So the skills and knowledge gained from this kind of work are really important for preparing to tackle real-time security threats. So so coming to the demonstration, my friend Salman will be taking over from here. So I'll invite Salman.
Hello everyone, I am Salman. So I'll be giving you a detailed demonstration of our project, including the offensive and the defensive side of the project. So let's head over there. Yeah, so let's start our demonstration with the server setup. So we have set up our server using Linode, which is a cloud service provider. Here we have gone with 1 GB of RAM and 1 CPU core for the keylogger server, which is based on Ubuntu. Now this server has 1 GB of RAM, which should be sufficient for storing of keystrokes. And we have been assigned a public IP address. So to go inside the server, we will use SSH and the username root at the IP address of the server. It will prompt us for a password. So we are in the server. To set up the Ubuntu server, we have used Express Server Basic, which sets the server up for capturing and storing of keystrokes. To do that, we have to go inside this specific directory, Express Server Basic. Once we are in, we just have to start our application, which is nodeserver.js, to be able to start listening to the keystrokes. So before we do that, let's start with the keylogger itself. So heading over to the virtual machine where we created a keylogger. So here we can see that there is a keylogger Python file. Let me open it up. So this is our keylogger file. So we have used PinePut library which is a library that captures all the keystrokes from the keyboard and sends it in a ASCII2 format. And then we have also other libraries necessary for this task. Then we have the IP. We have set the IP address of the server that we created earlier. This states to the code that all the keystrokes need to be sent to this specific IP address, and we have also assigned a port number which is 8080, and we have set a time interval of 10 seconds. So every 10 seconds the keystrokes will be sent to the server. And then we have also added some print commands for us to be able to see what's happening in the keylogger. So this is a basic keylogger Python script. Now the main task is to convert this .py file to an exe file. To do this, we will be using NUTCA, which is a C compiler used to convert .py files to an executable Windows executable exe files. To do this, we just have to install NUTCA, which is very simple. Using pip install NUTCA, you will be able to install NUTCA, and then we use this command pym NUTCA, and we specify the Python file which needs to be converted to an executable. Our Python keylogger file name, Python file name is keylogger.py. So I have mentioned that here, and once we hit enter, it will start recompiling the code from Python to an Windows executable using C compiling. Once that's done, we will have a keylogger application file. Now this file is ready for use. Now this file can be sent to the victim using social engineering or any other methods. To demonstrate this, I'll head over to the victim machine, which doesn't have Wazuh installed. So before I do that, here let me show you the Windows Defender. So under Windows Security, if we dismiss this account protection, since I haven't logged in using Microsoft account, yes. So you can see virus and threat protection is on, and under virus settings we have real-time protection on, cloud delivered protection on, automatic samples submission, tamper protection, and we also have browser control. Everything's enabled, and if I go to device security, see all the settings are turned on, so everything is running as per usual, and we are using latest Windows software, Windows 10, with all the updates. Now if I run the keylogger, we will be able to capture the keystrokes from this machine. Now, before we do that, let me do a side-by-side view. With our SSH. Before we begin, we have to set our server into listening mode. To do that, we'll have to write node server.js. So we have our app listening on port 8080. So once our server is set up on listening, the victim needs to do is double click on the keylogger file, and the keylogger will begin. So we can see that the keylogger is successfully sending all the data to the server. To demonstrate it, let's open Notepad and type hi everyone. So we see that the keylogger is successfully sending all the keystrokes to our server. Here we see the key shift, which indicates that the shift key was pressed, and all the data has been successfully captured. Now we'll demonstrate the same with another machine which has Wazuh with it. So coming to this machine, I have the same keylogger file, but I don't need to execute the keylogger file because the Wazuh detects its presence beforehand. So even its existence in the machine alerts the Wazuh for vulnerabilities. So let me open that. So this is our machine with Wazuh. So this is the IP address of our machine. Let me do a side-by-side view. So our IP address is 192.168.26.143, and in Wazuh, this is the Wazuh dashboard. So we have one active agent here. So after entering the credentials, we are able to log in to our Wazuh dashboard. It will take some time to load. We have two total agents and one active agents here. So under active agents, we can go to this device, which is desktop IRD M2E. This is the device, and we see the IP address 192.168.26.143. So this is the device, same device with Wazuh client installed here. And if we see, to detect it, we have set some configuration under module management and rules. And if I type keylogger, so we see that we have made some custom rules in our Wazuh rules policy. If I open this, we have, if the keylogger is detected, so it should be a level 15, which is very high in severity, and the ID also. If we go under agents, and this is the device that we have, we see the operating system, the IP address, and we also see the compliance. So we can set Wazuh for the compliance to GDPR, NIST, HIPAA, and all others. And then so many different vulnerabilities and security events were detected. So we are interested in the keylogger one. So to do that, let's head over to modules. And under events, we have, yes, we see Python 3.9.9. So this is the exact file which has been detected. And if I try to open this, it will take some time to load. Yes, so we are able to see that vulnerability detector has successfully detected this as a vulnerability, and the severity pattern is critical, and it has also listed all the other related rules which has also been triggered with this file. So in conclusion, we have successfully completed both the attack and defensive side of our project. I would like to ask my friends to come up here. So this was our presentation. Thank you.